we looked to actually a variety of different data sets and found this 5 sets of data are in a very structured format and also map with how our research is designed. And for Euler projects that we collected from Zoning Application Portal, it actually has all the records of projects have to go through Euler, and also all the notes and meeting minutes and documents and results. And DOB job application filings has a lot of building characteristics, a lot of detailed data about the projects. And for population fact finder is also a very comprehensive demographics data for each different breakdown in each neighborhood, etc. For 311 requests, this is probably the most interesting data set that for a lot of you. It would just record any type of 311 request through through almost all of different ways of portal for people to report, and also how they were handled and what type of complaints they are and what locations they are. And lastly, for the console constituent services, it is almost like a different way of a portal for people to report or have different requests, but then it's actually a more specific request for council members, which we think is actually probably more related to the topics that we were researching for. And for the data that we collected, we actually had to go through a process to clean up and do some work with the data so that they will be used for us. For example, we had to filter out irrelevant data categories, we have to match formats, and we had to clean up and reassign blank data cells. We also have to reformat the identifiers in order to join all different data sets together. And following that, I will show you very quickly what each of the data set looks like. You're looking at the zoning application portal, which we were collecting all the Euler process records. And as you can see, it's a very clear table indicating each step of the process and its outcomes. And also it has a very clear project ID and also date and time of each of the, and here's an example of the distribution of disapproved and approved projects on the right side. And you might be more familiar with this data set, which is coming from the NYC Open Data Portal. It has, as I mentioned before, it has a lot of detailed data specific for each project that was recorded. Basically, they were approved or just were okay to build, and then they start to apply for permits to build. So this will collect a lot of structured data with detailed information. And the population fact finder also is a very comprehensive portal data, and it actually allows various breakdowns that you want to aggregate your data. For example, we chose the neighborhood breakdown because that is the level of resolution that we were analyzing with. And then 301 requests, this is also from the NYC Open Data Portal, and it has very detailed descriptions and complaint types and descriptor that help us to identify how the distribution of different types of complaints are related per neighborhoods. And then the console constituent services, this is, again, it's coming from NYC Open Data Portal, and it has similar structure of like different types of requests. And we were able to pull out the ones that are related to building and housing.
Yeah, thanks, Betty, for introducing the data we used. So here I will briefly go through the methodology. This is a model we used in our research. So for this work, we basically choose to train a decision tree on those data sets, which is available to us. So the reason we pick decision tree is that for our research goal, the ultimate goal is not like train a model which can run smoothly in production, and it's more like a fun insight within the data set. Because during the data collection, our data set is not it's not a full data set, it's kind of like biased data set. So we want to learn more about the minimum for insight from the data set. And also training decision tree, which makes the model more easy to interpret. So for decision trees, there are actually 2 types of trees, and one's known as a classification tree. So basically for this type of tree, it will be a set of like feature and it will generate a categorical result. There will be like another type of tree called regression tree, and I didn't use a regression tree in this work because the regression tree used to generate some continuous value or numerical result based on the feature. So people may ask like, why not use some numerical model like logistic regression? The reason being that the data we collected already have high dimensional features, and also we don't have that many of samples. So by simply introducing a numerical model, and this may cause overfitting issues. And also for numerical models, we need to carefully normalize those features to make sure that they're easy to optimize for the model itself. And also another disadvantage for model like logistic regression will be that essentially it's still a linear model. So it cannot capture feature interaction as decision tree did. Yeah, next slide. So here, basically the workflow we use to do the experimentation and try to get the insight with. So from the diagram, you can see that basically we have 4 different stages. And for the first part, we basically join the data we collect from the data source, multiple data source. And after that, we unify the label within each sample, because usually what we got from the Euler project is not like a simple approved or disapproved. They have more smaller class outcomes. So we unify those results into a binary classification. After that, there will be a stage for feature selection. The reason we have this stage is that we have a high dimensional feature for each of the sample. If we throw all the features into the model training, the model will overfitting. And so here we basically combine our own hypothesis to choose a subset of feature fitting into the model and try to generate some result from that. After that, we will train a model based on those feature set. And we will measure the model performance using different metrics. For example, we look at the precision recall and F1 score, and also some score like AUC. These metrics can tell us like how the model performs on the data set. And if one of the model or one of the data set performs really good on the data set, we think that model might learn some meaningful result were inside from the data set. So after that, we can take a look at the tree more closely and to decide that what's the meaningful result we can extract from the tree. Yeah.
So we ran the model many different times with different combinations of features. So next page, basically imagine this kind of process. So here we have our model, the machine that's able to make predictions. And then say we tell the machine that we have, okay, these are the buildings that you see in New York City that got built after having Euler approval. But then we begin to feed the machine with different layers of information. Sometimes we tell the machine this is the location of the building. Sometimes we tell them this is the demographic conditions of the area, and then let the machine to make determinations whether or not that building has gotten community board approvals in the beginning. That's the process. And then here are our main takeaway. We found that the locations are the best predictor of community voices. When we feed the project's community board and borrow information into the model, the machine was able to build a pretty, a decision tree that's pretty useful and make pretty good set of determinations of whether or not the project has gotten support from the community board. The area residents' interaction with city council is also a somewhat useful indicator of community approval patterns. That is to say, to the machine, if you don't give it anything else about the project characteristics or the area's population traits, but just feed it information about how many city council complaints that the area has and how much of those complaints are housing and building related, the machine is still able to make a somewhat good determination. Then when it comes to other factors, such as the characteristics of the project, the demographics of the area, and the pattern of 311 complaints, a little bit to our surprise, they are not so useful for the machine. In other words, in our data sets of the build projects, these 3 feature sets at the bottom don't seem to be the most relevant in terms of correlation with community board opinions. So back to our original questions. Are we able to find out different levels of support or lack of support for development among New York City neighborhoods? Yes, because locational factors are the best predictors of outcome. We conclude that in our data set, we have indeed found different levels of support from different neighborhoods, specifically Midtown Manhattan, West Village, Chelsea, and Riverdale in the Bronx are some of the places where the highest concentration of community-opposed projects eventually got built. Then second question, are we able to pinpoint factors that can explain the different levels of community support or non-support? So this one, yes, and besides location, the other indicators are not showing the strongest result. But no result can mean something as well. It probably means that for the projects that got built through ULERP, some communities are more likely to have initial non-support, regardless of the characteristics of the project and the demographic. Or maybe the characteristics of the project, in fact, determines whether or not the proposal will get the final approval by city planning and the city council, and whether or not the community board disapproval will be ignored depends on something else. New York City neighborhoods are quirky. People in different places may like or dislike development for different reasons, and whether or not community opposition can influence the final outcome can also vary from place to place. Think about it. Maybe the result implies that it is the inner workings of the individual community boards, their priorities, and also their politics with the city that determine what the initial community voice sounded like and how that voice can or cannot influence the final building out. Next page. So in other words, with these data sets, we could not decode the full complexity of community voices, but we did hear some traces of them in binary form, and were able to know where the initial disapprovals of the projects that eventually got built tend to concentrate. A good next step will be to find additional data to understand why, and Betty will share more about our own reflections of this first stage research in the next and final section.
Thank you, Xiang. So let's have some discussions that we wanted to talk to you about. And yeah, one of the major pain point that we were having was about the data size. So as you can see from this diagram, the available data was actually much more than what we were able to process for our model. There are a couple of reasons. For example, they're not structured that we can just clean up and directly pull into our model, or they're just not available in the portals or the platforms that we were researching on, or we were not able to match the precise identifiers between the data set that we can analyze all of them together for correlations and decision trees. So we were thinking, if there were more data, what would be different, and could we have insights or more accurate results? And this could be expanded for different directions. So one of them is, can we convert the unstructured data into structured data? So this concept of structured and unstructured is basically structured data is almost like the table of data you have seen on the NYC open data and other Department of City Planning portals. And the unstructured data is actually more of the textual or PDFs or even images format of data that, for example, the zoning application planning portal have the meeting minutes or the notes or letters associated with the project for the ULERP process. If we were able to make those data structured, we are able to actually capture all the projects that went through ULERP process, and also add in a lot more project characteristics along with those for DOB process. And the other dimension of this is we are able to collect a lot of the quantifiable data. And once the unstructured data converted into a structured data, would we be able to find a bit more of the qualitative characteristics that you're not often can find from any of the data portal? And this will be very interesting. And we imagine this would be also more related to a design process or a community sentiments. And similar dimension of the first thing that I was talking about was, because a lot of the projects in NYC actually didn't have to go through ULERP process. So there weren't very well-documented public available data for those projects. So we were thinking, if those are available, then we are able to map them with the DOB data, because DOB data is whenever you have a project you need to build, then you have to apply for permit, then you have to fill in detailed information, but we won't be able to match other like feedback data for the community as we got from the ULERP process and database. So we were thinking maybe reach out to other not as public data or private data, for example, media, news, or other platforms of discussions for the community. But of course, there is also a question related to this is, should we make these data publicized? What would be other consequences following that if we actually make the step to make that more available for researchers or others? I think we were able to take advantage of actually a lot of the available structured data for this research, but we also think it is in the best interest for the community, developers, and the government to fully understand neighborhood sentiments. So it would be great if the data, if data like ULERP data, more accessible for researchers to find additional ways to decode them, and other useful data sets, we might be able to find more interesting insights or useful insights. Cool. And that is all we have to share today. And thank you very much for listening. And I hope you found it interesting. And let's jump to questions.
I think we have one question from Linda right now. She was asking who funded this project.
And you want to take it?
So this is our own hobby. We do not have founders, but if there are organizations, Linda, that you think should be interested in this, definitely let us know. We're interested in pursuing this further if there's additional resource to work with.
And if anyone else have any questions, feel free to just unmute yourself and speak out, or any thoughts or comments.
Hi.
Oh.
Hi, sorry, I'm Dan, I'm from the UK. I found it really interesting listening to how you collected the data and really explored the community voice. I'm doing an MA in city development right now, and we just finished a module in how do you voice the city. We've taken it from a really creative background. So looking at it now from this kind of very statistical background is really interesting because it really puts it in perspective in terms of the infrastructure of the city. So I just found that really fascinating. And in terms of like gathering that kind of information and making it available to both communities, governments, and developers, are you trying to create a platform of communication? What is the real purpose behind this data collection?
Yeah, I can take this first, and then maybe Yuxiang can go on to chime in. I think the original goal for this research is really to find out if we can mitigate the process, the costly process for like inaccurate community voices representation. So we were hoping to build up a pipeline or a process to make that more available. For example, developers, if they want to design a project or get it built, they understand what are the most concerns that the community has, and then they can address the concerns as early as possible and as fast as possible. But I think you brought up a very interesting point is went through a lot of process gathering the data and make it useful for our pipeline, we didn't even get to other ways of collecting community voices. We were relying on all the available data source that we have. But I think you brought up a very interesting point. If we can more available for people, for the community, this will be actually a direct portal for them to share their thoughts. And maybe it's an even faster process for us to make the function or the features of our pipeline to make this process better, to make their voice heard better for other departments.
Yeah, just to add a little bit, as we do development and also planning in the States, we often find out that, yes, communication is very messy and information is very valuable. So for developers, as we talked about earlier, they have to go through a lot of process and invest a lot of dollars just to understand how people think. We don't think that our data platform can replace that process, because when you engage people, new information find out. But if you can understand how people think before talking to them, then I think they can really develop some strategies to anticipate some of the frictions down the road, and also develop strategies in their communication and also in their building design to respond to that, so that the possibility of failure can be less. And also for the residents themselves, ourselves, say if I really like a project, but I know that my neighbors all hate it, if I have that information, then I will talk to my neighbors effectively prior to those meetings, so that making sure my voice, which is the minority voice, is heard. And then if I'm in the majority, then that can also enable me to develop a coalition that's early on and acting efficiently. So a lot of the information, I think, that's circulating among different people in the whole planning and development process eventually got lost due to the ineffective communication and also the lack of publicity, if you will. In a way, even though we only use community board as the window to look into how people think, we do acknowledge that community board is not, if there are ways of making people's voices more public, more heard, then that can potentially lead to a better version of engagement for the public and private party. I think we have a few more questions in the chat. Jennifer was asking, how did you come up with the original idea? What inspired that? I can start and then Betty, you can jump in. So when we were first chatting, I think over the new year, about urban planning in the States in general, we all come from different backgrounds, and also we worked in different countries previously. We noticed that like the extraordinary amount of community engagement and stakeholder engagement that government and private developers need to go through in the States. And then, as we know, many of the planning process, like building design, structure design, they are being automated by firms, the one that Betty is in. But so we were trying to ask, is there a way for the human aspects of community engagement to not be automated, but also to be understood through a data-driven insight, so that the kind of inefficiency, the messiness that we just described earlier could be streamlined a little bit, and also giving people who don't normally come to those meetings a chance to get their voices heard. So to answer your question directly, Jennifer, in my opinion, the inspiration was the extraordinary amount of engagement that we see in the States regarding planning and development. And we see a potential of using data to streamline that process a little bit so that the different actors will gain something from the process.
Cool. And then there's a question following as from team. Great info. How would you define the success of using this machine learning / determining real estate projects? That's a great question. We have been also thinking through how do we define this project, if it's successful or not. But we thought that having some insights coming out and using this approach that we chose was a level of success that for us, and also determining there were no correlation or no insights for some of the aspects that we experimented with was also almost a hint or like a direction for us to actually either choose a different approach or choose a different data set or there were problems that we have to go back and evaluate. I think for the insights that we were able to share today, we hope they were interesting and also inspiring for the next steps, for follow-ups, for people who are curious with the similar questions to actually go out and look at the data that we collected and maybe to look for even better data source or raise some concerns or suggestions to, for example, organizations like NYC Open Data to share more or less of the data. So I think that's how we think about if our projects were successful. But Yuxiang and Bowen, feel free to chime in.
Yeah, just one more thing I want to add. So for this stage, our results is more like interpret how the model makes decisions. But if we consider like introducing more data in the future, and I think another successful result from using machine learning model would be that if we have a larger data set, it's possible that we can train a better model, which can actually be used for evaluating the project before they actually apply for Europe. So that would be some other benefit, but that will require more data. So that's currently not available to us right now.
And the next question from, how do you say that name? Alice? Alice. Okay, sorry about that. Alice, have you considered who the developers are, e.g. larger institutions with money, a lot of money, or small ones as part of the feature set?
So in a way, when we use the DOB data, Department of Buildings, when they file job applications, they have to fill out the type of ownership. So they say like this is a corporation, this is a partnership, or this is a city government. This is HPD, this is NYCHA, something else. So that kind of information is captured in our features. However, we don't have information regarding the capital behind those organizations. And that will be something that's interesting. I think maybe DCP and their Euler questionnaire can try to probe a little bit. But for now, we only have information from DOV regarding the type of ownership, but not the power, if you will, behind each organization. But I agree, Alice, I think this is a pretty interesting indication and possibly will potentially having implication and correlation with people's oppositions or lack.
Yeah, I just noticed that a lot of the examples that you provided with your neighborhoods on that slide where you had like Q1 and Q2, like question one and question two, a lot of the neighborhoods you listed require, if you think about how much capital it takes just to build in those neighborhoods, it's a lot. And so I wonder what it would look like if you actually can bifurcate the difference between like large institutions and smaller development projects.
Yeah, maybe another interesting point, maybe we can, because I doubt it that companies will willingly disclose their entire capital stock in those questionnaires. But I think for DOB, they did ask for the cost of those projects at some features. I can't recall exactly whether or not that's showing strong results, but overall, at least at this stage, none of the DOB characteristics showed up as being really like strong in terms of becoming the predictor. But again,
I almost wonder if you can take like either SEC filings for publicly traded companies, in which case they like list their revenue, or something like if you look at Manhattan landlords by square footage, which you can get from like an RCA or CompStack, and then if they show up in the top 100 or something, that they're a large institution or something like that.
Yeah, that's a good idea. Thank you.
Cool. Next question from Paul. Actually, you have a few. I'll just read them all. And I have missed it dealing with small children in the background. But was there a correlation between volume of development in a given community versus the tone of support/objection? And can I check that you found no correlation to, say, economic standing of residents to propensity or to objects? What is it about the geography of the scheme that you think is correlating to the response from the community? Yeah, we're happy to answer them. Yuxiang, go ahead.
Yeah, so this one, Paul, just to clarify a little bit, and then in a way we were also struggling internally in terms of what's the most accurate way of describing the result. So let's say our finding is not about a simple binary form of support versus no support, because our entire scope is limited to ULERP projects that eventually got built. So say that a community board might oppose a project, that project might be also opposed by the council in the end, versus that project might be approved by the council at the end. So our scope only contains the project that eventually got approved by the council. So when we say that there's no correlation between volume of development versus the community support or objection, we are really saying that for projects that eventually got built, there's no correlation. However, say if we are able to get all the data about the volume of development for ULERP projects that actually got objected by the council as well, maybe there will be correlation, because the hypothesis is maybe physical characteristics like height, building use, if those factors are like so abhorrent, so crazy, then they will be guaranteed to face objection from both the community and the government. However, for our data, we didn't really have reliable structured data about ULERP projects that got objected by the government in the end. We're limited to only studying buildings that you see in New York standing right now that got approved. And then looking at those buildings, we saw no direct correlation between how big they are and whether or not the communities hated those at the beginning.
I guess it was more a question of the number of schemes rather than the size of any individual scheme. So if there was a community, I think you named Manhattan, I imagine that they are under constant, it's like a constant barrage of schemes coming forward, and maybe it just beats the community down into submission. So perhaps you're seeing the greater the number of schemes in a given community, the less likely they are to bother objecting to any given community, any given scheme. And I'm wondering if you see correlation there. So if there's a community that's not used to, perhaps they...
Yes, that's a great idea, I think, for us to add maybe in the future scenario, because right now we're not putting the overall number of developments that communities need to go through as one of the features for their decision. So yes, as you said, for a community board, if they go through a lot of projects in a given year, like the Manhattan board that we mentioned earlier, maybe that's giving them a little bit of like more tendencies, I don't know, positive or negative for them to object or approve a project, but I can definitely see them as potentially related.
Thanks. Great work, by the way.
Oh, thank you. And also your second question regarding the economic standing. Yeah, again, a similar response to that. I definitely have read research linking economic standing and demographics to positions to ULURP. Basically, academic research tend to conclude that the more wealthier a neighborhood is, the more homeowners there are in the neighborhood, the more likely they can overturn a ULURP project because of their strong opposition. However, same limitation in our study, we're only looking at projects that eventually got approved. So many of the successful objection coming from wealthy neighborhoods might be they are excluded in our data set. So we are looking at only a very narrow scheme of basically whether or not the initial objection become overruled by the city council at the end. So I guess that's telling a different story. In a way, maybe as we see, it's really related to the politics of the boards and the council and nothing else, at least on the first glance that we are seeing right now.
Do you have a way of identifying the difference between the politics of the board and the council? In the UK, and we have a Labour and Conservative sort of Republican Democrat. It's quite clear to see. It's quite clear to see the politics of a given group. Whether you see any linkages between the politics at play.
Yeah, for those of the audience who have been to a community board meeting for those developments, you definitely see a really interesting dynamic in terms of who tend to speak in those meetings and also who had the time and the energy to go to those meetings. And then from what I know, many times before ULURP, developers, they will meet individually with the council member or the leader of the community board to make sure that whatever concern that they have, they in a way try to address those ahead of time. But again, the trick really is about how representative the boards tend to be. Are there other ways for the community members who are not in the board to be able to voice their concerns? And also, what does it mean by the health of the city eventually, both in the physical term, but also in the political term, to have these kind of voices heard at different stages or in a way not heard when they actually matter? Because again, community board decisions are not binding. We do see many cases where the support of the community board become objected by the council, or the other way, the objection of the board become ignored by CPC and the council in the end. I think for those of you who are interested, you can go to the zoning application portal to go to the project of your concern. And for those completed, you can actually read the full letter written by city planning. They will describe, okay, this is a project that was opposed by the community board because they all voted no for these reasons. And then I'm DCP, I concur because, or I recommend to approve anyway because of the following reasons. It's interesting to read those letters. And as Betty mentioned earlier, we were hoping that if we can find a way of translating those letters, those insights into analyzable data, I think that will potentially make this analysis a much more robust one so that we can actually hear, not just to hear the binary yes or no from the member, but also hear about like why they are opposing a project. Is it because of affordable housing? Is it because of some other things? Those will be potentially valuable additions to the feature sets. We have 5 more minutes. Any other questions from you?
Can you explain a little bit about like feature extraction from the unstructured data that you have? Because I find that, especially with decision trees, they're very subject, like you have to find the right feature space, especially when you have like text data. So can you just elaborate on that a little bit more?
So right now, the feature we use today is more like a structured feature. So we didn't like extract some other high-level feature from the text. But if you want to like with those data, yeah, like you mentioned, the decision tree might not be a good model for that. I think nowadays, when people want to incorporate like text data or, for example, image data into a model and try to generate some insight, try to do some prediction, they usually tend to use like a neural network. And usually one way to do that will be that you have a pre-trained language model. For example, nowadays people might know like a BART model and transformer model. They use those models to like encode all the text into a fixed set of vectors. And also there will be some model for computer vision as well. So basically those models can encode the text or image into a fixed set of vector. Then that vector will be used as a representation for those text or image. fit into the neural network, and then eventually they will be used to do the prediction. And the reason I mentioned that used per training model is that usually for the task, for example, for our project, the training data is kind of like limited. So it's probably not possible to train the model from end to end only using those data sets. So by using a pre-trained model on a larger data set, you can basically, the assumption is that you borrow some knowledge from those open data sets, and eventually those knowledge can be transferred into your your problem domain and generate some inside information. Yeah.
Okay, cool. I just found that it's the open data set, like pre-trained models sometimes don't capture all the context back into and transfers over to real estate, but happy to also talk about this offline.
Yeah, sounds good.
We have a new question from our friend in the UK. Going forward with the idea of creating a platform where efficiency of communication is the key between multiple parties, how do you maintain a sense of neutrality as the politics of all elements will be very different? Oh, that's a great question. Anyone want to take this? I personally have not thought that far, but happy to hear about your thoughts. Do you want to unmute yourself and talk about this issue?
I was just thinking, because I'm thinking you're dealing with such different elements. You're dealing with the local community, and you're dealing with developers that will have an economic drive. And I'm in London right now, and there's a lot of development that's happening, and it's not necessarily considering the local communities. So I'm just wondering, when you start creating these platforms of three-way communication, how do you then maintain that sense of neutrality, not get pulled too much down the developers route, or maybe pull too much down the community kind of arts kind of groups? How do you maintain that middle ground? And I'm thinking that kind of possibly collaborating with multidisciplinary groups and things like that would maybe your best bet. So I was just wondering if you'd thought about that, because the idea just popped in my mind. And how would you then go ahead and do that? And the only way that I can see is that kind of, as I said, multidisciplinary kind of collaborations.
Yeah, I think another way to talk about this is through the lens of ownership, like which entity eventually is the organization that's in charge of collecting and distributing the data. Say that, because if this platform can be built from a technical point of view, then say if that's in charge of by a private company who sells the data to different people versus a public agency like New York City government that's making the data fully transparent and accessible on the web, I think that will have two very different outcomes. And then
to add on that, I feel like having more transparent information from people who are proposing for projects to happen to the community, it would definitely promote more thinking and more in-depth thinking, or more targeted opinions from the community towards development. Will help the process a bit easier to understand the balance between different forces. But it's definitely a very interesting, important that for a lot of the community, let's say free communication is very hard for anyone to make sure it got to an effective result. And also sometimes even we say it's a free communication platform, I think most of the time you will still be capturing voices that are rather louder than those are quieter. So I think we have to understand that bias as well to make it a bit less not neutral. I think we're on time, and thank you again very much for coming to our talk, and I hope you enjoyed it, and the questions or thoughts and ideas and comments that you all shared with us were very inspiring and very interesting. Yeah, and I hope this will bring some insights to all of you and to everyone who's interested.